So in this, we can talk about what we call the SeeSaw method in reindexing power series. So the SeeSaw method, the SeeSaw method for reindexing a power series. So this is a method that I developed like about a few years ago, and it makes it really easy when you want to reindex a power series. So it can be applied to any kind of problem like that. So we're going to use to reindex to use to reindex power series. So for example, this is the question what we're trying to do. Let's say you have a power series which is going from 2 to infinity, n minus 1, cn x to the n minus 2, like that. So the question is, can you rewrite the same one, for example, starting with n equal 0 to infinity, like that? So if you do that, what's going to happen to this side? So that's the one we're trying to understand. So there are textbook methods to do it, but it can be complicated sometimes because you try to pick a different variable and you try to set it to n minus 2 and like that. But we talk about a very quick way to get the answer. So let's try it again. So it's called the SeeSaw method. So SeeSaw method. So what we're trying to do, just imagine a seesaw, how it works. So for example, let's say so there are two people. It's pivoted at a point. So so what's going to happen? One people go down, the other one go up. So like that. So that's the situation. So the idea is, you can see that both people go up and down so that the pivot doesn't change. So that's this number doesn't change, but the two people go up and down. So that's the same idea what we're trying to use here. So this one can go up. At the same time, this one can go down by the same amount. So there are two situations here. So you can see one goes up, the other goes down by the same amount. So let's say k amount. Or this one go down, that one go up by the same amount. So that's the thing. So one on the left side, we're gonna say the outside. This time I'm gonna call it outside for a reason. This is the inside. Now let's try to look at the problem again, what we're trying to do. So we had this problem. So we had a sigma n going from 2 to infinity, n minus 1 cn x n minus 2. So what's going to happen now? So what we can do is, so with the same argument, for example, let's say you want to rewrite this one using an index of x to the n. So that means what you want to do is you want to increase the index of this one by 2. So this side we're going to increase by 2. That's the inside part. So that means outside you're going to decrease by 2. So that means it's exactly the same as sigma n going from 0 to infinity. Why 0? Because you go down by 2. And inside everything, all the n's, we're going to increase by 2. That means the first one going to be n become n plus 2. N minus 1 become n plus 1. So you add a 2. Just add a 2 to everything, all n. And then cn becomes cn plus 2 because you add a 2. And xn minus 2 become xn because you add a 2. And that's it. So that is the new power series. It's just a representation. It's the same power series, but just a new representation which use xn instead of xn minus 2. And sometimes we have to do that, especially when you try to solve differential equations using power series method. So let's look at a few cases. So let's see how freely we can change the index. So we can talk about few other cases of the same problem, but with different indexes. So let's do that. So let's say, so I'm going to start the same problem. So the sigma n equal to infinity n minus 1 cn x n minus 2. So the first one what we did was we increase this by 2, this side by 2, decrease that by 2. So let's rewrite that again. So that means it's sigma n going from 0 to infinity, because you decrease by 2 and you increase everything inside by 2. So it is n plus 2, n plus 1, cn plus 2, xn. How about, let's do another problem. Here let's try to increase, let's try to start with n minus 1 terms instead. So here we start with xn. Let's see how we can do n minus 1. So if you want to go n minus 1, that means you only need to increase by 1. So you do increase by 1, this one decrease by 1. So if you do that, then your new sigma going to be sigma. You will only decrease by 1, that means it's going to extend 1 to infinity, because you decrease by 1 only. And inside you increase by 1. So you start with the original one. So it is increased by 1, that means it's going to be n plus 1. The next term going to be n. And then c, this beginning n plus 1 is going to be x to the n minus 1. So you can do it like that. So here you can see we start with n plus 1. Here we start with n equals 0. So you can do freely. So let's do one more. So how about this one? So let's say we're going to start with n equal 3 here. So that means if you want to go in n equal 3, you want to start with n equal 3. What you want to do is you want to increase this one by 1. That means you have to decrease inside by 1. So this is going to increase by 1. That means n equal 3. For some reason, let's say you want to do that. And then inside you want to decrease by 1. So that means it is n minus 1, n minus 2, c n minus 1, x n minus 3. So you can see this is very easy. So you can simply do like a SeeSaw. What you're going to do, outside you increase, inside you decrease, or outside you decrease, inside you increase. So what we did again, so either outside decrease, inside increase, or the other one is outside increase, inside decrease. That's it, by the same amount. Okay, if you keep that, then it's not going to change the series. You can see that all those 4 power series represent the same series. Okay, so that's the interesting part. So let's write it. All these represents the same series. So that's the interesting part. It's just give the exact same series, because this is very useful when you try to solve differential equation problems. So let's try to look at a few more examples in different cases. So let's do more practice problems. So practice problems. The first one, let's try to do rewrite with the power of xn. Rewrite with a power of x to the n. Okay, so the first problem. So let's say sigma n equal 3 to infinity n cn x to the n minus 3. So if you look at this problem, you can see it is n minus 3. That means you need to increase inside by 3. You have to decrease outside by 3. So that means your answer going to be, you decrease the index by 3. This means n equals 0 now to infinity. Inside you have to increase by 3. That means this is going to be n plus 3, c n plus 3, and then x to the n, because you increase by 3. You just add a 3. I mean, that's it. Okay, so let's do another one. How about this one? Sigma, let's say n equal 3 to infinity n minus 1, n minus 3, 2 to the n minus 1, Cn x n minus 2. So if we do this one, so what's going to happen? So the same argument, to get the xn, like before, to get xn term, you have to increase this one by 2 now. Okay. So you have to add a 2. So that means this one go down by 2. So let's do that. So if you do that, you're going to get sigma n equal, you're going to go down, that means you can start with 1, infinity. You have to add 2 to inside. You have to add 2 to inside. So then you can see that this is going to be n plus 1, and then n minus 3, if you add 2, it's going to be n minus 1. This is 2, if you add a 2, it's going to be n plus 1. This is c n plus 2 x to the n. That's the interesting part, because you just add a 2. Okay, so very easy. And you can see that sometimes, you can simplify. For example, if you simplify this part, it's going to be n squared minus 1. So it makes the problem much easier compared to the original one. So that means you can rewrite this one again using n equal 1 to infinity. This is n squared minus 1, 2 to the n plus 1, Cn plus 2 xn. But you can see that this simplification you could not see in the original one, but now you can see it, especially this simplification part, this term. It was not there before. So that's the benefit. Sometimes make it some calculation much easier. Let's do another one. So how about this one? Sigma n equal 2 to infinity negative 1 to the n power 2 to the n plus 1 Cn minus 1 x to the n plus 1. I know there are a lot of cases here. So let's say you want to start with this one again by n. So we have n plus 1. That means you have decreased by 1. That means you have increased by 1 outside. So that means your simplification going to be sigma n starting with 3 now, because you increase by 1. And then decrease everything inside by 1. That means this is negative 1 to the n minus 1, because you decrease. And then 2 to the n minus 1. And then this simply becomes n now, because you subtract 1. And c n minus 2. And then x to the n. So that's what happened in this case. So you express everything simply as a power of xn. Okay. Good. So that's one type of problem. So what's the first type of problem? You're going to rewrite the power series as a power of xn. Okay, write the series as a power of xn. Let's do another one. So let's see how we can combine several power series into one. So that's the most important one for problems that we want to do in differential equations. So when you want to do that, you need to remember a few things. So the first thing is, let's say when combining, when two or more summations, when two or more summations are combined or added, when two or more summations are added, write the uncommon terms first. So that's very important. Write uncommon terms. Write uncommon terms first. So it will be very clear what we mean by that when we do the first example. Because when you have two power series, we don't know whether it's going to generate the exact same powers of x. So if if it is not the case, what we're going to do, we're going to rewrite the uncommon terms first, and then we start writing the common terms using the same index. So and also this is another way to remember that what we normally do is we're going to substitute the first index value to the series, and then we're going to see what you get. And then what we're going to do, we're going to leave the largest term and write only the smaller index terms. Okay, so leave the largest terms. Largest terms. Why we say terms? Because maybe two series have the exact same term, but not the other one. So like that. That's why I say terms. Leave the largest terms and write only the smaller terms. Write only the smaller indexed terms. Smaller indexed terms. So it will be very clear once you do the example. So let's do this problem. So number 2, the second type, write using a 1 power series. Write using 1 power series. What does that mean? Let's say the first example. Let's say we have these 2 power series, sigma n going from 2 to infinity, 2 to the n plus 1 Cn x to the n minus 2 minus 3 times sigma n equal 1 to infinity n minus 1 Cn xn. Let's say this is what you have. So if this is the one you have, what we normally do is we're going to see what you get if you plug in the first index. So if you plug in the first index for the first series and you plug n equal 2, you see that you're going to get x to the 0. If you plug in the first index for the kernel, that's the first index, n equal 1. If you plug n equal 1, that's the first index, you're going to get x to the 1. So that means those are not the same. One produces x to the 0, the other one produces x to the 1. So what we're going to do, we write the uncommon term. The uncommon term is x to the 0 because after the second index comes, you're going to see that they are exactly the same. So we write the uncommon terms first. So what's the uncommon term? In this case is from the first series, you plug in n equal 2, that's the uncommon term. So that is 2 to the 2, and then you have n plus 1. So you can write 3, but since this first example, I write like that. And then C2 x to the 0. You can write x to the 0, it's okay. Minus, now you can see after that everything gonna be the same. So we write the rest of the series. So it is n plus, you're gonna start with, because you plug in the first value. First value is 2. So this is for n equal 2 value. So now what we're gonna do, we're gonna start with n equals 3 in the power series because we already wrote the first value. So it's the same series, so 2 to the n n plus 1 Cn xn minus 2. But we know that the other series only have x to the start, because you can see now when you put n equal 3, you're going to get x to the 1. But the other series automatically have x to the 1. So I'm going to bring 3 inside. So that means it's going to be plus. Oh, actually, it's okay. You can leave the negative sign here to avoid confusion. So minus. I'm going to bring 3 inside. If you bring 3 inside, it's going to be n equal 1 to infinity 3n n minus 1 Cn x to the n. Now what we can do, we're going to reindex. So you can see here you can bring, because we already have xn there. So what we normally do, we try to write using xn. It's easy to work with. So we're going to bring this one by we're going to bring this up by 2. We're going to bring this down by 2. So if you do that, then you can see your series is going to be, here you can simplify. 3 plus 1 means 3, so you get 12. So it is 12 C2, x naught is 1, we don't write it. So let's reindex. So if you're in a reindex, it's going to be, you're going to go down by 2, that means it's going to be 1 to infinity. And then inside you up by 2, that means it is 2 to the n plus 2. You up by 2, that means n plus 3. Cn plus 2, this can be x to the n now. Why? You increase by 2. Minus sigma. Here this is already xn, so we don't do anything with that. So we just leave it. Now what we can do, you can see they are exactly the same thing with the exact same index. So what you can do, you can simply combine the two. So let's combine the two. Once you combine the two, you're going to get 12 Cn plus just 1 sigma. So I'm going to write n going from 1 to infinity. And then we're going to put all these terms inside one bracket. So this is 2 n plus 2, and then n plus 3, Cn plus 2. Now the rest one. So minus 3n, n minus 1, Cn. We write everything outside as xn. So you can see, you combine both series. Actually, it's xn is n. This is 2. So you combine everything into one power series. Okay, so that's the idea. So what we do, you use the SeeSaw method to rewrite the power series using as a one power series. Okay, but still you're going to see some uncommon terms outside because there's no way you can bring it inside. So what we normally do, you leave them outside. So this is the uncommon term that you were talking about. Good. So let's do more. Okay, you can see it's not that difficult. So I'm just going to do a few more examples just to make it clear. Maybe you already know what's going on here. Good. Let's do 2 more. So number B. How about this one? Let's do like one with 3 terms. So n equal 2 to infinity, 3 n minus 1, n minus 2, c n minus 1, x to the n minus 1, minus 4 sigma n equal 1 to infinity, n c n minus 1, x n plus 1, plus here n going from 0 to infinity, n minus 1, Cn, xn. Good. So again, let's look at the first few terms. So if you apply n equal 2, you're going to get x to the 1 here. When you apply n equal 1, you get x squared here. When you apply n equal 0, you get x to the 0 here. So you can see, so the largest term is x squared, so we leave it. But you have to write first few terms. From the first one, you have to write x. You have to write the first term, and the next term is starting with x2. But for the second one, you have to write 2 terms. You have to write x0 and also x1, because then after that you get x2, so you start giving the same one. So you have to write 1 term from the first series, 2 terms from the second series. Let's start writing them. So that means this is equal. Let's write the first term. But you can see when you plug in n equal 2, what's going to happen? Because of the n minus 2 factor, this is simply 0. So you don't get anything. And then everything good, because the next term is x squared, so it's matched with the next one. From the last one, when you plug in x equals 0, n equals 0, you're going to get negative 1, c0, x to the 0, plus when you plug n equal 1, you can see the next term is 0, so that's gone. So that's it. Now we're going to rewrite the rest of the power series with the rest of the index. So the first one, you only need to plug in one value. That means you start with 3. That's very important, because you already write the first term. So start with 3 infinity. Then you can see this is 3 to the n minus 1, n minus 2, c n minus 1, x n minus 1. From the second one, you can rewrite as it is. So it is 4 sigma n going from 1 to infinity, n c n minus 1 x n plus 1. And then let's say plus, for this one you although 2 terms, that means you have to start with n equal, because you had 0, you had 1, you already had, you have to start with the next one, that means 2. And this is n minus 1 c n x n. You can see there are no changes for the other part. You just rewrite a different index. This is the only one you change. Now what you're going to do, you're going to SeeSaw method to reindex them. So what are you going to do now? So you can see, so here you're going to increase this one by 1. You're going to increase this one by 1, decrease by 1. Here you're going to decrease by 1, increase by 1. Here no change. Okay, no change. So let's rewrite using the new index now. So what's going to be so here you have negative C naught. That's the only one you're going to get. Plus, let's use the reindex now. So if you use the reindex, this is going to be n going from 2 to infinity. Inside you can increase by 1. So it's going to be 3n now. And then this is going to be n minus 1. Because you add 1. Just add 1. So we can see n xn. Perfect. And then minus 4 you can bring inside if you want. So it is n going from 1 to infinity for 4. Now what you want to do? You want to decrease by 1. So that means n become n minus 1 now. And then c n minus 2 now. And then this is going to be x to the n because you decrease by 1. And then plus, you can see that it's xn already, so there are no changes. Actually, let's see whether I can write here. I don't know if I have space there. So it's going to be sigma n going from 2 to infinity n minus 1 c n xn. Perfect. You can see now everything has xn, 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 same index. Actually, what happened here? So I think there was a mistake. So this has to be, because you increase this one by 2, so this has to be 2 now. So you can see they all have the exact same starting value. So that means you can simply combine all of them. So n minus 1 is common. You can rewrite that outside. So that means it's going to be negative c naught plus sigma n equal to infinity. So you can see n minus 1, so I pull it out. And then you have 3n cn. From the next one, you're going to have 4 cn minus 2. And the next one, you're going to have, because you pull out the n minus 1, you have only cn. And then you write the common xn outside. Now you can see that there are a little bit more simplification going on. You can combine this with that. So finally, we have negative c naught plus sigma n equal to infinity n minus 1. Inside you have 3n plus 1 cn minus 4 cn minus 2 xn. Okay, so that's the final simplification. We can use these in when you try to solve differential equations. So let's do one last problem. So the next one is part C. So we do like a couple of examples so that it's like very clear to you. Let's see this. So let's say n equal 3 to infinity n minus 2 cn xn minus 1 minus sigma n equals 0 to infinity n cn xn plus 2 plus sigma, let's say n going from 2 to infinity cn xn minus 1. Again, the same thing, we try to check what you're going to get for the first index value. When you say n equal 3, you're going to get x squared. When you apply n equals 0, you're going to get x squared. When you apply n equal 2, you get x to the 1. So that means you only uncommon term is x to the 1. So we're going to rewrite that first. So that means if you plug in x1, so you're going to get c1 x, and you can see the rest is good. So we're going to rewrite them. So n equal 3 to infinity n minus 2 cn x n minus 1 minus sigma n equals 0 to infinity n cn xn plus 2, and then plus sigma, you write the first value, so you have to start with the next value. It means 3 cn xn minus 1. So what changes we did? We changed this value. And the goal is to rewrite all three using the same index, same x powers. Then you can combine them. So what you want to do in the first one, we're gonna this one increase by 1, decrease by 1, and then here decrease by 2, increase by 2, here increase by 1, decrease by 1. So let's do that now. So then what's happened is c1x, that's what you get, plus sigma n equals, so it decreased by 1, it's become 2 to infinity, so this is increased by 1, it's become n plus 1, and if you add 1, it's become n minus 1, and then c n plus 1 xn, that's what you get, and then minus, here you increase by 2, so it become n equal 2 now to infinity, decrease by 2, so n minus 2, and then c n minus 2, this become xn. From the last sum, you're going to get sigma, you're going to decrease by 1, that means n equal 2 to infinity, and then c increase by 1, n plus 1, increase by 1 xn. So now you can notice few things, same power, same index. So that means you can combine all three into one. So let's do that. So it is c1x plus, and then also we see that there are any common terms. Unfortunately, there are no common terms, so only this common index and the common power. So and also you notice that this part simplifies to n squared minus 1. That's some benefit. So we can write this one as n squared minus 1 then, and then we have cn plus 1, and I'm going to put a bracket there, minus, and then here you can see n minus 2, cn minus 2 plus, from the last one you can see it is cn plus 1, and then we provide the common power outside. Now also see whether there are any other simplifications that you can do. So you can see you can combine these two. So what happens when you combine those two? When you combine those two, we have n squared minus 1. There's a 1 there, minus 1 get cancelled. So you can see the minus 1 term gets cancelled with that. So that means finally you're going to get c1 x plus sigma n going from 2 to infinity n squared cn plus 1 minus n minus 2. You can also multiply by the minus sign and write n minus 2, but this will be much better because at the end what we can do, we can use this for solving series. Then this form is useful, so we leave it like that. And then this is going to be n minus 2. So yeah, that, and then xn. So that is the common simplification for this 3 power series.